Imagine a scene where a heavy-wheeled truck, despite its massive engine, finds itself buried in deep, thick mud. The more the driver accelerates, the deeper the tires sink, churning the earth into a sticky grave. Now, imagine a main battle tank, a machine weighing more than 10 of those trucks combined, approaching the very same ground. It doesn't slow down. It doesn't struggle. It glides across the sludge as if it were cruising on a highway. Some modern tanks weigh over 60 tons, yet they navigate terrain that would trap a standard off-road vehicle in seconds. How can a 60-ton tank move across mud, snow, sand, and broken ground, while a much lighter wheeled vehicle gets trapped? The answer lies in engineering. While tracks provide three major advantages, their biggest benefit isn't what most people think. To understand why tracks are essential, we must address the core engineering challenge. Tanks are incredibly heavy. To survive on the modern battlefield, a tank carries thick layers of composite armor, massive high-velocity cannons, ammunition, fuel, and engines capable of producing 1,500 horsepower. All of the weight creates an immense downward force. On a traditional vehicle, all the weight presses directly onto the ground through the tires. Because tires have a relatively small contact area, that weight is concentrated into a few specific points. On soft or unstable terrain, the pressure is so high that the ground simply gives way. The vehicle sinks until it bottoms out, losing all ability to move. The central question for engineers has always been, how do you spread tens of thousands of kilograms across unstable ground? This weight problem is the primary reason why tracks are preferred for heavy armored warfare technology. This leads to the first major advantage. Tracks are masters of spreading weight. This is best understood through ground pressure. A standard tire touches the ground over a relatively small oval-shaped area. Even with large off-road tires, that contact patch is limited. In contrast, a track creates a long, wide contact patch spanning almost the entire length of the vehicle. By doing this, the tank's weight is distributed across a much larger surface. Think of it like this. If you walk through deep snow in normal shoes, you sink instantly. But if you put on wide snowshoes, you stay closer to the surface because your weight is spread out. Tank tracks work like massive, powered metal snowshoes. Despite weighing 60 tons, a tank may exert less ground pressure than a human standing on one foot or a family sedan, allowing for superior tank mobility. However, spreading weight is only part of the story. The second advantage is that tracks create truly massive traction. While a tire relies on a small bit of rubber gripping the road, a track system utilizes dozens of heavy metal links gripping the ground simultaneously. These tracks are designed with aggressive, raised patterns called grousers that bite into dirt, mud, and snow. As the track rotates, it continuously lays down a fresh, stable gripping surface for the road wheels to roll over. This ensures the engine's power is transferred into forward motion rather than just spinning wheels in place. When a wheeled vehicle loses traction on one tire, it often gets stuck. But because a track has a massive surface area in constant contact with the earth, even if one part slips, other sections continue pulling. But traction still doesn't explain how these giants can turn within their own length. That brings us to the third advantage, the unique way tracked vehicles navigate tight spaces. Traditional wheeled vehicles require a steering rack that turns the front wheels, creating a wide turning circle. In a combat zone, you do not always have the luxury of space. Tanks solve this by controlling the left and right tracks separately. By slowing down or braking the track on one side, while the other continues to move, the tank naturally pivots toward the slower side. For even more extreme maneuverability, many modern tracked vehicles can drive one track forward while simultaneously driving the other in reverse. This allows the tank to perform a pivot turn, spinning 360 degrees while staying in the exact same spot. This is vital because battlefields are often filled with rubble, narrow forest paths, or destroyed buildings. A tank can simply spin and face any threat. Beyond moving and turning, tracks allow these machines to conquer obstacles that would stop any wheeled vehicle. The design of the track system itself is built for climbing. The front of the track usually angles upward toward the drive sprocket, which helps the vehicle pull itself up and over vertical obstacles like walls or fallen trees. Furthermore, the long, continuous base of the track allows the tank to bridge gaps. While a wheel would fall into a narrow trench or a wide crack in the earth, the track simply spans the gap, supporting the vehicle until it reaches the other side. This is supported by multiple road wheels and a suspension system that lets the track flex and contour to uneven ground. Whether crossing a deep trench, climbing over mounds of urban rubble, or traversing steep, muddy slopes, the track system keeps the vehicle moving where wheels would simply fail. However, these incredible capabilities come with a hidden cost that militaries must manage. Tracks are not a perfect solution. They are a series of mechanical compromises. For starters, a track system is incredibly complex compared to a simple axle and wheel. It consists of hundreds of individual metal links, pins, and bushings, all of which are under constant stress. This complexity means they require frequent inspection and grueling maintenance. If a single pin breaks or a track is thrown off its wheels, the entire tank becomes a sitting duck. Furthermore, tracked vehicles are noisy and vibrate intensely, making long-distance travel exhausting for the crew. They also consume significantly more fuel than wheeled vehicles because of the friction and weight of the tracks themselves. This is why you often see tanks being moved on heavy trailers. It saves fuel, reduces mechanical wear, and prevents the metal tracks from damaging public roads. Knowing all this, you might wonder, why not build tanks with giant wheels? If wheels are more efficient, wouldn't making them bigger solve the ground pressure problem? While giant wheels could technically improve obstacle clearance, they introduce new engineering nightmares. Huge wheels would make the vehicle much taller, creating a massive target. Protecting those large, exposed wheels with heavy armor would be nearly impossible without adding even more weight. Steering systems for giant, heavily armored wheels would also become incredibly complex and prone to failure under combat conditions. Most importantly, even the largest wheels wouldn't provide the same continuous ground contact that a track offers. In essence, a track system allows a tank to bring its own road with it. It creates a smooth, flat surface for the internal road wheels to travel on, regardless of how jagged or soft the actual ground is. This does not mean tracks are universally superior for every mission. In many cases, wheeled armored vehicles are actually the better choice for modern military operations. Wheeled vehicles offer higher top speeds on paved roads, better fuel efficiency, and a much longer operating range without needing mechanical repairs. They are also quieter, providing a level of stealth that a clanking tank can never achieve. In environments with established infrastructure, a wheeled vehicle can deploy quickly, cover hundreds of miles, and arrive ready for action. This creates a clear distinction when comparing tracked versus wheeled vehicles. Tracked vehicles are designed for the most extreme terrain, heavy armor protection, and raw obstacle crossing power, while wheeled vehicles are optimized for speed, logistical efficiency, and rapid deployment. Understanding this balance is key to knowing how modern armies choose their equipment. It is a matter of matching the right tool to the specific environment. In summary, the reason tanks use tracks instead of wheels comes down to three fundamental benefits that outweigh the high maintenance costs. Tracks spread the tank's enormous weight to prevent it from sinking. They provide continuous traction over unstable surfaces, and they allow for incredible maneuverability in tight, cluttered environments. When you see a tank really effortlessly crossing a deep trench or climbing over a pile of rubble, you're seeing the result of very specialized engineering. A tank does not use tracks because wheels are completely outdated. It uses tracks because carrying massive armor across terrain with no proper road requires the vehicle to literally bring its own road with it. If you found this breakdown of armored vehicle mobility truly interesting, now let us know in the important comments. What should we explain then next? Why tank tracks come off, or how high-speed tank suspension keeps the crew stable?